Welcome back. Part 2. Here we go. So after class, we didn't quite have time, or we didn't have nearly enough time. But that's because I talk a lot. I'm going to try not to do that. Here we go. So we've got our second optimization problem. I suspect this will be a minimization problem because we already did a maximization problem. So here we go. Mr. Boutros wants to invest up to $20,000 in two stocks, Cal Computers and Texas Tools. The Cal Computers stock is expected to yield a 16% annual return, while the Texas Tools stock promises a 12% yield. He'd like to earn at least $2,880, very specific. And I want to highlight the at least here, this year. And according to the safety index, Cal Computers has a safety number of 3 and Texas Tools has a safety number of 2. How much money should he invest in each to minimize the safety number? Okay, and so a lower safety number means less risk, although I would say that's kind of backwards, but whatever. So we're asked to minimize the safety, which is going to be 3x plus 2y, which means, let's start with x and y, right? Our x must have the safety number of 3, which is the Cal Computers, right? And so what are we measuring with x? It's the amount that we've invested in Cal Computers, right? So just like the last question, okay, you want to make sure that you don't miss. I'll skip the constraints just briefly, and since we're talking about it, let's just fill in what x and y are, right? For 1 mark, easy. It's the amount invested in Cal Computers, which means y has to be Texas Tools, right? Has a safety number of 2, that checks out, okay? And so it's the amount invested in Texas Tools. 1 mark in the bag, easy. Huh? Our constraints, we don't have a lot of constraints. In fact, there's really only 2 that we need to be concerned about. Okay? And so we have our x plus y, which is what? The total amount invested. Okay? So this is the total invested. And here's our yield, right? And so he'd like to earn at least $2,880 given the 16% and the 12% yield. So we've got the 0.16x and the 0.12y has to be greater than or equal to 2,880. Okay. And so here, I'll just call it the yield. Okay. And of course, you can't invest a negative number, and so we're stuck on the positive axes. Okay. There is a typo on here, which might have been confusing. I'm missing a 0. Makes a huge difference. And so the 10 to the power of 4, if you'd done it on your calculator, you would see that it's 10,000. And so I'll correct this, and hopefully that makes it make more sense. Okay. It's only because I program the axes and it doesn't like large numbers. And so otherwise, so on the test, if we have large numbers, I'll just have them as the actual numbers. So no need to worry. Okay. So 2.5, for example, starting here, 2.5 times 10 to the power of 4 would be $25,000. Okay. I'll just make a note of that here. And so 2 would be $20,000. 1.5, $15,000, etc. Now we're asked to minimize the safety number. What do we need to do? Well, we need to draw our lines first, right? So first thing we do, we have to draw our lines. Then we have to sketch our feasible set, right? And from our feasible set, we need to find our vertices, right? Or our intersections. So let's call this line 1 and this line 2. X greater than 0 means we're on the positive y-axis, and y greater than 0 means we're on the positive x-axis. I've already done that part for you. Okay. So we just need to do line 1 and line 2. I'll do it the same way we did with the earlier one. So we have line 1, which is x plus y is equal to 20,000. Okay. And we need two points on this line. Okay. I like to let x be 0 and then let y be 0, right? Because then I have some anchor points, right? If x is 0, that's on the y-axis. So if x is 0 here, then y must be 20,000, right? So that's nice. And of course, if y is 0, then x must be 20,000. So 20,000 is here and here. And again, I'm going to use a straight edge. I just use the edge of my calculator, but it does have a little ridge, so it won't be perfect, but it'll be good enough. Boink. Connect those dots, draw the line. Now we're not going to use our line, it's just to make sure that our answers are reasonable and to sketch the feasible set, and so you don't have to spend a ton of time making sure it's perfect, okay? Because you won't be able to. Line 2 is slightly more complicated. 0.16x plus 0.12y has to be equal to 2,880. Okay. Do the same thing again, right? Any 2 points are fine, right? As long as your line looks like mine, doesn't matter. Okay. And I'll do the same thing again. I'll let x be 0 and then let y be 0 and see what happens. Okay. Now, if x is 0 here, right, then this goes away, this becomes 0, and I get 2,880 is 0.12y, which means that y must be 2,880 divided by 0.12. So 2,880 divided by 0.12 makes 24,000. Doing the same thing with y equals 0, I get 2,880 divided by 0.16, and I get 18,000. So we'll start with this point. Oh, and I forgot to label that this is line 1. Okay. Start with this point here. When x is 0, y is 24,000, which would put us at 2.4, right? And so I'm just going to put it just slightly below here. It's not, as long as you're somewhere between 2 and 2.5, maybe closer to 2.5, should be okay. And when y is 0, x is 18,000, which would put us at 1.8, right, on this scale. And so somewhere close to 2. How about there? Okay. So now I'll connect these. Line 2. Okay. Now we've got our lines. Feels good. Okay. What's our next step? We have to find where these constraints are satisfied, both of them at the same time. Okay. And so let's see here. If you're comfortable with these inequalities and something if something has to be less than a number, then you're below the line, and if it has to be greater than, then you're above the line, right? That's good. Let's try to sketch that out. Let's see here. So, has to be below line 1, whoops, which is here, and line 1 was here. But it has to be also uh, ba, 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 above line 2. Okay. So at the same time, has to be above line 2. Now, when I look in this region, I don't have the overlap, right? Because line 2, I have to be above line 2. Okay. And there's lots of different ways that you can do it. You can shade the areas that satisfy the constraints, right? Or if there are a lot of constraints, what you can do is you can shade the areas that are not satisfying the constraints. And then the area that's left over, not shaded, would be your feasible set. We haven't done that in class, so but it is a nice trick to have up our sleeves. The only area, right? So moving through our possible areas here, it can't be here because line 2 isn't satisfied. Okay. It can't be here because neither of the lines are satisfied, right? It can't be here because line 1 isn't satisfied. So all we're left with is this little tiny region here, right? That's okay. So our feasible set, gonna try to shade it in here, looks like this. Okay. What's nice about this? Well, I have I have 2 of the 3 vertices, right? So that's kind of nice. Okay. Um, we can pick a point, although from my scale, it's a little bit hard to see what would be in there, but let's, what's a point that would be in here? 0.25 maybe here, and 1.75. Let's try that as a test point. So use 0.25. Oh, sorry. Use 17,500 and let me just make sure, 2,500 as a test point. Okay. That's assuming that I picked a point that's actually in here. I really hope it is, because if I'm just slightly off, I'll have to try a different point. But this is optional, right? If you're able to figure out which area you want with just the inequalities, that's great, right? But we use test points if we're unsure, right? Another thing you could do, I guess this area is kind of tricky too. Another thing you could do, very tedious, is you could try a test point in all the regions that you know don't satisfy it to confirm they don't satisfy it. But that seems tricky too. So hopefully this is in our region. So let's see here. We've got 17,500. So for line 1, plus 2,500. Let me just confirm. It is 20,000. Okay. looks like I need to move down a little bit. I picked a point on the line. That wasn't on purpose, but it still is less than or equal to 20,000 fifth. If you wanted to get this less than 20,000, what would you need to do? Right? You would need to either move down on the y-axis, right? Or move down on the, or to the left on the x-axis. Right? Two options. Right? But I'm happy with that. And line 2, 0.16 times 17,500 plus 0.12 times 2,500. 5. Oops. Maybe I did too many zeros earlier. Nope, it's okay. 17,500 times 0.16. Uh-oh. Let's see, 2,500 times 0.12. Maybe I picked a bad test point, I think. Hmm. You know what I'm gonna do? First off, I'm going to go into Desmos instead. So I can see the grid better. In fact, 20,000, I'll just do the inequalities. Oh no, my Desmos. Ugh. This is the feasible set. Let me just pause this. I'm just gonna, I'll fix my Desmos. I'll be right back. I'm back. I know, no change for you, but I did some stuff. So from Desmos, we can confirm that we had the right feasible set, right? So Desmos shades, you can use inequalities. Of course, you won't have it on the test. And so, but you can confirm, right, that the overlap is that little sliver. Now, where I was off was I'm going to use a point at 2,000 instead of 2,500, and I'll use 17,000 instead of 17 and a half. I think I used 17 and a half before. So I've corrected it from my better grid, right? Turns out eyeballing it is kind of difficult on this scale. Okay. So if I change it to 17,000 and 2,000, which I saw from Desmos is a reasonable test point in this area, okay, then it does indeed check out that both of the constraints are satisfied, right? So the first one is less than or equal to 20,000, and the other one, the next one is greater than or equal to 2880. Finally, can move on. So this is our feasible set. Okay. What's great is we have two of those vertices. Okay. We only need to do work for B. So now we have to find the intersections. I guess this, you don't have to tell me that's what you're doing. So I'll do it in light blue. A. A is the intersection of line 2 and y equals 0. Okay? And so from here, right, we know that that should be at 18,000 from earlier. So we've already done that work. But you do have to tell me that you did it earlier, right? Otherwise, I want to see the work. B is the intersection of, well, should be line 1 and line 2. We only have 2 lines. Of line 1 and line 2. Okay. Line 1 was the x plus y is equal to 20,000. And line 2, 0.16 x plus 0.12y is 2,880. Line 1, line 2. Huh? I think this one is a nice substitution option. You're welcome to use elimination. However you want to find the intersection is fine by me, right? And so I'm going to use substitution, and let's solve for x in line 1. Solve for x in line 1. So x is 20,000 minus y. Okay. Substitute into line 2. 0.16 times x, which is now replaced or substituted with 20,000 minus y, plus 0.12y is equal to 2,880. Expanding this, I get 0.16 times 20,000. Make sure I have enough zeros there. I get 3,200 minus 0.16y plus 1.12y is 2,880. Subtracting 3,200 from both sides, I get 2,880 minus 3,200. I get negative 320. And collecting like terms with the y's, I get negative 0.16. So negative, oops, let me do it, 0.16 plus 0.12 gives me negative 0.04y. Solving for y, I get negative 320 divided by negative 0.04. I get y must be 8,000. Let's go back to our graph and make sure that that seems reasonable before we continue. Okay, so we're told that y should be 8,000. This is 5,000. This is 10,000. Looks reasonable to me. All right. So we can solve for x. Now x is 20,000 minus y. And so here, now solve for y, or sorry, solve for x. X is 20,000 minus, you know what? I'm going to bring it back. I should probably write down what I'm using. X is 20,000 minus 8,000. Just as we expected, 12,000. All right, go back to the graph, make sure that makes sense. All right, somewhere between 10,000 and 15,000 on the lower end looks like 12,000 to me. Nice. So B must be at, B is at 12,000, 8,000. And luckily C, this final intersection, well, this intersection is at line 1 where y is 0, right? And so when y is 0 in line 1, x is 20,000. So we've got 20,000 when y is 0 from earlier. It's our next step. We're so close. Next, we have to evaluate the objective function. We have to dust that off and bring it back with us, right? And so what's our objective function? we wanted to minimize the safety rating, which was 3x plus 2y, okay, at each of these vertices. So we list our vertices, vertex A, B, C. Kind of cute when you only have three vertices. And we've got our safety. Oh, I forget. 3x plus 2y. Yes. 3x plus 2y. Vertex A was at 18,000, 0. B was at 12,000, 8,000. And C was at 20,000, 0. Notice in A, you're not investing all of your money, right? You're not investing your full 20,000 that you have, so that's kind of interesting. Not something that matters, but an interesting thing. Okay. So we get 3 times 18,000 plus 2 times 0 is 54,000 in terms of a safety rating. Okay. Now we want to minimize the safety rating, so we're looking for the smallest one. All right. So let's move on to 3,000 times, or 3 times 12,000 plus 2 times 8,000. I get 52,000, which is interesting because now you're investing all of your monies, right? But you get a lower safety ratings, which is a good thing. Yeah. And finally, 3 times 20,000. I already know it's going to be the biggest value, right? Plus 2 times 0. I'm gonna go for 60,000, but let me confirm. There. So we have our answer, right? The goal was to minimize it, and so we choose the smallest value. And so therefore, the safety is minimized to 52,000 units. I don't know what the units are. When X is $12,000 and Y is $8,000. Now, if I was being proper, of course, I would say X is the amount in the Cal Computers, I think it was, and Y is the amount in the Texas Tools, but that's okay. I'm not going to do that. So you don't have to either. Nice. Finally, on to some logic. Conditional statements, right? If I show my work, then I can get part marks. Yes, that's true. We have to write the converse as a sentence, write the inverse as a sentence, and of course, write the contrapositive as a sentence, which means the first thing we need to do, right, is assign some proposition shorthand, okay? On your formula sheet, I give you this, which we're going to use, so I'll bring it in here. So if we're given a conditional statement like this, if P, then Q, right? Remember, that's how we read these. Okay. And so I want to translate this into a P and a Q. Okay? So if P, then Q. Okay? If I show my work, oops, I went too far. That'll be my P. Then I can get part marks. That's my Q. All right. Because the shorthand for this statement would be if P, then Q. The converse, okay, I'll do it in A here. The converse is if Q, then P, right? That's from your formula sheet, but I want to see that you know that. Okay? And so as a sentence, if I get part marks, then I showed my work. If I get part marks, then I showed my work. Huh? Oh, I guess gotta be careful. These aren't in the same order. That's okay. We'll keep you on your toes. B wants the inverse. The inverse is if not P, then not Q. Okay? So here the inverse is if not P, then not Q. Okay? Not P would be if I do not show my work, then I will not get part marks. Right? Negating each of these. If I do not show my work, then I will not get part marks. Right, the contrapositive. And the contrapositive is if not Q, then not P. Okay. So if not Q, then not P. Okay. Not Q is if I don't get part marks, then I did not show my work. Notice how I'm massaging the sentence structure a little bit. You're allowed to do that. You're also more than welcome to just keep the propositions exactly as they are. It's going to sound weird, but that's fine as well. Okay, so either way is fine. If I do not get part marks, then I did not show my work. Nice. Okay. So taking that conditional statement and reworking it into the converse, the contrapositive, and the inverse. I think this one I can just do beside here. Here we're told what to assign each proposition to be. So if M is I like math, if P is I will pass this course, and A is I will do my assignments, we have to express each of the following propositions in symbolic form. I like math and I will pass this course. Okay? That sounds like M and P to me. Okay? I will do my assignments or I will not pass this course. Okay? And so here, I guess I like math was M, and I will pass this course was P. I will do my assignments, that's A, or I will not pass this course, which is not P. So the answer then is A or not P. Remembering the order for these logical connectives, right? The negation is done first. So if you want, you could put some brackets around the not P to indicate that you should do that first, but you'd have to anyways. Next one's a little bit tricky, right? It is not true. And so the following statement is not true. That I both like math and I will do my assignments. Okay? And so here, like math is M, and will do my assignments is A. Okay. So together, right, if we ignore that it's not true for a second here, right, then we have M and A. Okay. But then we want to negate that. It's not true. Okay. So then you have your negation out front, making sure to wrap it up in brackets. That was a tricky one, right? I will not do my assignments and will not pass this course. Okay, this one's different, right? Because I will not do my assignments. That's not A. Oops, A. And I will not pass this course, not P, which puts me at not A. And if you want, you can put brackets around, although order of kind of logical operations here tells us that you have to do the negation first anyways, but it might be nice to show, and not P. Nice. Okay. Oops. Hey, doesn't wanna work for me. Okay. Oops. That's not what I want to do. I wanted this one. Provide the truth table for the compound statement below. Is the logical statement a tautology, a contradiction, or neither? And you have to explain, right? Explain why. Okay. And so what's a tautology? At the very end of your truth table, once you're all done, your final column is all ones, right? Always true. Contradiction is when you end up with a final column of all zeros, right? Always false. Okay? And if you've got a mixture, then it's neither, right? And so that would be your explanation. So first thing we need to do to make a truth table, right, is figure out how many propositions am I working with, right? If I only have two, which I do in this case, right, P and Q, I only need 4 rows. That's nice, all right? If I have 3, I would need 8 rows. Okay. Oh, and I did promise, give you a heads up, there will be one with 3 rows on the test. Or sorry, 3 propositions, which means 8 rows. Okay. So P, Q, here we go. 0, 0, 1, 1. 0, 1, 0, 1. I'm going to build out not P first. Okay. Then I'm going to make a column of Q or P. Okay. And then I'm going to bounce between the two for the final statement. Okay. Not P is 1, 1, 0, 0. Right? Just negate P. And Q or P. As long as one of them is a 1, then you're safe. Right? You get a 1. That's what I mean by that. 0 or 0 makes 0. 0 or 1 makes 1. 1 or 0 makes 1. And 1 or 1 makes 1. Okay. Now, not P, bouncing back and forth between Q or P means I'm bouncing between these two columns, right? I didn't have to do a ton of work for this one. It's only true if I'm bouncing between the same values, right? And so here I'm not, so I get a 0. Next row, I am going between a 1 and a 1 and a 1 and a 1, and it's happy, so then I get a 1. And then for the next two, it's bouncing between a 0 and a 1, and so those are both 0. Since the final statement is not all ones nor all zeros, it is neither a tautology, I'll say nor a contradiction. Good. You want to show me that you know what it means to be a tautology and a contradiction. If you just say neither, that's not full marks. Right. Finally, which is good because I'm running out of time, gotta go to my next class. Construct the truth table for the following compound proposition. First thing we have to do for the truth table, and so we're not asked to find if it's a tautology or a contradiction, just the truth table. Okay. We have to figure out how many propositions I have. I see a P, I see a Q, and I see an R. We can do it. 8 rows. Right. P, Q, R. Okay. If I have 3, then I need 8 rows, right? Which means I need to start with 4 zeros and 4 ones. 0, 0, 0, 0, 1, 1, 1, 1. Now, alternating, alternating that's annoying. How do I turn this off there? Good. Do not disturb. We're busy. Now for Q, I want to break up, right, the zeros in half. And so half the zeros get a 0, and then half the zeros get a 1. Same thing with the ones. 0, 0, 1, 1. Same thing with the R's. Now we just alternate, right? Half the zeros get a 0, half the zeros get a 1. Same thing. 0, 1, 0, 1, 0, 1. Ah. Now what? Well, different options, right? It might be nice to start with not P and then go to not P and R. I'll do them in the order that they appear, and so I'm going to do a column of P or Q. Okay. P or Q is these two columns, right? As long as one of them is a 1, I get a 1. And so I get 0 or 0 is 0, 0, 1, 1, 1, 1, 1, 1. For some reason, it makes me happier when I can get a 1. It's true. Next thing I need to do, right, just from the brackets too, is I need to build out the not P first, right? If you're comfortable doing it in your head, you're allowed to, but I wouldn't encourage it, right? It's kind of tricky. So I like to make a column of not P, and then you can do not P and R. So not P, 1, 1, 1, 1, 0, 0, 0, 0. Now not P and R. This column, not P and R. In order for and to be true, they both have to be 1s, right? Anything else, 0. 1 and 0, 0. 1 and 1, 1. 1 and 0, 0. 1 and 1, 1. 0 and 0, 0. 0 and 1, 0. 0 and 0, 0. 0 and 1, 0. Hopefully I did that right. Finally, the connective. Okay, this conditional statement. So if P or Q, then not P and R. Okay. So now, instead of writing it all out, I'm just going to copy it, paste it here. Okay. Because now, do you remember the conditional statement? It's always true, except if you go from, what is it, a true statement to a false statement. Oh, I should check that. It's been a while. Yes. So if you go from a true to a false, then it's false. Otherwise, it's always true. Careful with this one. Okay, so I'm going from here to here. So from a 0 to a 0 gives me a true. From a 0 to a 1, that's true. From a 1 to a 0, that's a 0. From a 1 to a 1 is a 1. And then it looks like all the rest of them are 1 to 0s, which is the baddie. 0, 0, 0, 0. And just like that. That's the end of the practice test. And be prepared for a 3 proposition. But notice how the table's not that big, right? But you can do it. Just remember the 8 rows. I'll see you on Wednesday.